6.10, it's all about special cases, and this is a way that when you recognize these binomials as how they are, like if you have x plus 3 times itself. No, it's not just x squared plus 3 squared. Okay, you got to actually write it like this, x plus 3 times x plus 3. If I take you through this, you know, x times x, x squared. Cross over x times 3 plus 3x. Cross over here, 3 times x is a plus 3x. And then these last terms multiplied, 3 times 3 plus 9. What ends up happening is you get, actually, this is the first term squared in the binomial. This is the first term. I gotta get my pointer here. The first term times the last term doubled. See that? First term times the last term is 3x, doubled is 6x. And then this last term of the trinomial down here ends up being the last term times itself. So you just get 3 times itself is 9. So we're actually showing you a shortcut so you don't have to show all this work right here. You can recognize it and go, okay, this is x plus 3 times itself. I know that you're going to get the first term squared, that's the x squared. I know that the middle term of the trinomial is going to be this x times this 3, that'd be 3x, doubled, right? So it's going to be 6x. I know that the last term of the trinomial is going to be this last term times itself, 9. So over here, instead of having to go through all of this stuff, you could go, oh look, it's 2x minus 5 times itself. Okay, I know that that's going to be 2x times itself. 2x times 2x is 4x squared. It's going to be this. I know that the middle term is going to be 2x times a negative 5. That'd be a negative 10x, doubled negative 20x. Okay, and you can see that when you show work, but eventually you show so much of this work, you're going to see this pattern emerge. And then I know the last term of the trinomial is negative 5 times itself. So negative 5 times negative 5 is a positive 25. Okay. Here's how they put it in the book. They say, anytime you have a plus b, the quantity squared, what you get is a squared. Then you get, in the middle term, you get a times b, which is ab, doubled is 2ab. Then in the last term, you get this last term here, whether it be positive or negative, squared. So you get b squared. Okay, that's one of the special cases. The other special case is when you have this, 2x plus 3 times 2x minus 3, where they're the same terms but they're in each of the binomials, but the signs are different. So what happens when you multiply this out, 2x times 2x is 4x squared. 2x times positive 3 is plus 6x. 2x times a negative 3 is a minus 6x. You notice this middle term cancels out. And then a positive 3 times a negative 3 is negative 9. So what you get is, in essence, when it's like this, you get the first term squared. 2x times itself is 4x squared. You get the last term times itself. 3 times 3 is 9. And there's always a minus in here because remember, it's a positive times a negative. It's a minus. So it ends up being like this. A plus b times a minus b. You actually get this term squared. There's going to be a minus this term squared. So let me show you one. Let me show you. Okay, so from the first one, let's say this is 3a plus 6 quantity squared. Anytime you see that, you can go, hey, I know a shortcut for this. That's this one squared, 3a times 3a, which is 9a squared. That's these two multiplied together and doubled. 3a times 6 is 18a. Doubled is plus 36a. And that's this term squared to be the end, so positive 6 times a positive 6 is a positive 36. There's your answer instead of showing all that jazz. Okay. The other one, let's say you had 9a plus 6 times 9a minus 6. And this is another shortcut we know because we thinking, hey, same terms, different signs right here. Okay, what ends up happening is Change my color here. We get this squared, so that's an 81a squared. We get this squared, so that's a 36. And there's a negative in between the two. So instead of having to show all that work, that's what you get. We'll do more of these in class. We'll do some of them out loud, so I think you'll feel confident with seeing those special cases.
Made with Doodlecast Pro.